Hey guys, so today's lesson is about scale factors. So we're going to be building a lot based on what we talked about in the last lesson, and we're going to be talking about a different way of calculating missing side lengths. So this lesson is all about scale factors, and a scale factor is the number that we multiply a shape's sides by when we're creating an enlargement or a reduction. So we were doing this yesterday, we just weren't calling it a scale factor. It can be written as a whole number, a decimal, a percentage, a fraction, or a ratio. If you do write it as a fraction or a ratio, make sure that you write it in lowest terms. So when we're calculating scale factors, it's really easy. We start by just identifying our corresponding sides, which we talked about in the last lesson, and then we just divide the corresponding sides or write as a ratio or fraction in lowest terms. It is important to note that if you are dealing with an enlargement, the scale factor has to be a number greater than 1. So that'll tell you which way you have to divide things. If it is a reduction, the scale factor has to be less than 1. So let's look at an example of how this would work. So in this case, I'm going from a larger shape to a smaller shape, so this is a reduction. These are already oriented in the same ways. So my 8 and 6 are corresponding sides, the 4 and the 3, and then the 1.6 and the 1.2. You can pick any pairs of corresponding sides to calculate the scale factor with. I decided to use the hypotenuse of both, but you could use any set of corresponding sides. So one of the ways that we can do a scale factor is to just divide the two corresponding sides. I'm going to divide the reduced shape by the original shape. And the reason for that is that I know that my scale factor when I have a reduction needs to be less than 1. And if I take a smaller number and divide it by a larger number, I'm going to get a number that's less than 1. And so I could record this either as a fraction in lowest terms. If I was going to do that, obviously 6 and 8 are both divisible by 2. So 6 divided by 2 would give me 3. 8 divided by 2 would give me 4. And now it's in lowest terms. So I could either leave it in lowest terms like this, or I could convert it into a decimal. So I would just actually divide 3 divided by 4, which is 0.75. Or I could also write it as a percentage. In order to do that, I would just multiply by 100, which would give me 75%. So any of those would be valid options. I could either leave it as a fraction, 3/4, a decimal, 0.75, or a percentage, 75%. I could also write it as a ratio. The only thing with ratios is that however you would write it in a fraction, the denominator goes first and then the numerator. So it's kind of like backwards of how you would write it when you're dividing, when you write it as a ratio, but it would also need to be in lowest terms. But any of those would be correct ways to represent the scale factor that we're dealing with here. 3/4 is less than 1, 0.75 is less than 1, and a percentage of less than 100% is also less than 1. Okay. In the last lesson, we talked about using proportions to find unknown lengths of sides. You can also use scale factors to find unknown side lengths. Obviously, you start by calculating the scale factor. If you do calculate it as a percentage, I would recommend converting it to a decimal. Actually, you need to convert it to a decimal, so you divide by 100 to do that. If you have it as a ratio, convert it to a fraction or a decimal. And then if you're finding the missing side on an enlarged or reduced shape, then you multiply the corresponding side of the original by the scale factor. If you're finding a missing side on the original, then you divide the corresponding side on the reduced or enlarged shape by the scale factor. So let's go through an example of what that would look like. So here I have a reduction that's taken place. I already have my corresponding sides in the same spot as each other. My triangles are oriented the same way. And in this case, the missing side that I'm trying to determine the length of is on my original shape, not on the reduction. So step one is going to be to find our scale factor. In order to do that, I take my new shape, so either the reduced or the enlarged shape, and divide it by the original. So in this case, I need to use the corresponding sides that I know both of the values of. So I'm going to do 4.5 divided by 6. And that gives me, once again, 0.75. So my scale factor in this case is 0.75. And you will sometimes have a question where it specifically asks you for a scale factor and then asks you for the missing side length. And then the second step is to take the corresponding side that I know the number of, so this 6 here. And because I am looking for the side on the original, I am going to divide the corresponding side by the scale factor. So divide by 0.75. And that gives me a side length of 8. So x is equal to 8. Okay. If I had known the side length of my original and was looking for the side length on my new shape, whether it's a reduced or enlarged shape, I would multiply by the scale factor instead of dividing. But because I'm working backwards, I have to divide instead. Okay, so that is how we find a missing side length using scale factor. Again, you can use this method or the one that we used in the last lesson where we cross multiply and divide using a proportion. Whichever one of those you prefer, you can always use either one when you're finding a missing side length. Again, sometimes you will, however, be specifically asked for a scale factor first, in which case that might be the easier method to use. In this last example here, now we have an enlargement that's taken place. We're also looking for the side length on our enlarged shape, not on the original. But we're going to start with the same first step, find our scale factor by taking the corresponding sides that we know the length of on both the original and the enlarged shape. We are going to do the enlarged shape, so the new shape divided by the original. So 5.27 divided by 3.1. We always do the new shape divided by the original. Again, this time, because we're looking for an enlargement, our scale factor needs to be above 1. So if we divide by 3.1, we will get a scale factor of 1.7, so that's above 1. That matches with the fact this is an enlargement. And then our second step is going to be to take the side length that corresponds with the missing one, so the 4.8. And this time, because we are looking for our new shape's side, we are going to multiply by the scale factor. And that gives us 8.16 as our x value. Okay, that's it for today's lesson.